Ladies and gentlemen, I welcome everyone. Thank you so much for joining us, and let me introduce you to our guest speaker for today, Paul Mertes. Big biography, but let me highlight some of the achievements. So Paul Mertes has over 20 years of experience as an executive directing the growth or turnaround of engineering, technology, and infrastructure companies. Paul has an undergraduate degree from University of Waterloo in mechanical engineering, and he has an MBA in finance from York University. And for the past 10 years, Paul has focused on the clean tech sector with clients involved in the provision and control of clean energy into buildings and facilities. So ladies and gentlemen, please put your hands together for Paul Mertes. Thank you.
Well, thanks very much. I really appreciate it. And in the preliminary talk, we did make a few comments about taking a walk down memory lane, and it's thrilled to be back at Waterloo. And I'd like to thank everybody here for coming out to see our presentation and to learn more about CircuitMeter. I'm going to start by just finding out a little bit about the audience. But before I do that, I'd just like to capture the imagination by showing a very brief video.
Every day, electrons course through our built environment, illuminating our cities and powering our enterprise. Yet, while this magnificent flow has shaped our economy, it is invisible, only perceived through static glimpses. For organizations trying to optimize their energy performance and mitigate their contribution to climate change, managing their electricity use, an invisible resource, is a game of guesswork. Not anymore.
I'm going to talk a little bit about the clean tech world that we're moving towards and the markets that are evolving and the magnitude of the shift that's required in decarbonizing our economies. But I'm also going to do it in the context of the business environment, the market opportunities, and how all this can be done while it's creating jobs and contributing to our economies. Before we do that, I'm just wondering, given that there's not a huge number of people, if I can get maybe a show of hands of the faculty, students, a few. Okay. Yeah. How many people can conceive of the thought that on a rooftop with 8 air handling units, all the same, 7 of them might be using the same amount of energy, but one might be operating fine on the surface, but it's using 50% more energy? It's detuned in some way. It's got a short circuit. Or in the middle of summer, an underground parking lot with a snow melt system has a warm ramp that's been working since the end of April, even though it should be shut off. Or an industrial factory in Etobicoke that has 4 stairwells with all the baseboard heaters on, while the inside offices are being air conditioned and the outside temperature is 23 degrees Celsius. These are all scenarios that in the last 3 years, early implementations of our CircuitMeter technology has discovered, and they're all emblematic of a couple of categories of what we call energy wastage. One are simply mistakes, things that just shouldn't be, control systems that misset, people have done things wrong, systems that have outgrown the complexity that they were intended to control, or perhaps inefficient use. Yes, they are supposed to be on, but there's a problem with the operation, or perhaps there's a bearing that's wearing. Yeah, 18 months ago it was working fine. Now the motor is working harder. No one knows there's a problem, but the motor is drawing 30% more amps, and the power consumption has gone far above benchmark, and yet operations continue. What we've got in all of these cases, whether it's in the commercial or the industrial world, or even in high-density residential, is a situation where the people that are in charge of paying the bills pay them. Once a month, their utility sends them a bill, and they pay that bill. And that is what we have as the status quo in the world today. There are entire industries that are built up to a certain degree based on metering technology, but more focused on control technology that work to make energy use efficient. There are ESCOs, energy service companies, that do portfolio management where they will do spot energy audits, and then they will build models, and they will make recommendations to the portfolio owners on how they can improve the energy efficiency. They'll finance that, and they'll make energy gains. There are sub-metering technology companies like Schneider, like Eaton, like Siemens that put out into the industrial world expensive sub-metering systems that are used in high value-added industrial systems in certain applications, but they are expensive. There are also sub-metering technology companies of previous generations, for what I'm going to talk about, that put sub-metering technology into high-density residential apartment buildings, condominiums, or shopping centers, essentially so that the landlord can offload responsibility for paying the bill to the tenant and make them responsible for the energy use. That's the status quo today. And what our models have shown us, and what the U.S. Department of Energy has made an estimate of, is that 30% of the behind the meter energy is somewhere in the neighborhood of 30%. Now, in the U.S., that calculates to approximately $75 or $80 billion a year of waste, and the figure is of the same magnitude in Western Europe. So, with the world moving towards a greater and greater focus on energy management, on energy efficiency, on decarbonization, and very, very likely an increase in energy costs, it seems only natural to believe that in addition to clean generation, in addition to energy storage, in addition to smart grid evolution, the whole fourth leg of the table, the whole area of energy management is going to come under focus, and management of facilities right the way across the economic spectrum are going to be looking for answers. And that's what we're all about. So I've got this big 10 billion figure up there. We believe this number is low. We've got this $80 billion number in the US alone. If you use a 4-year payback as a sort of a benchmark for what organizations might think is an acceptable return, that suggests that north of a $300 billion market may evolve, or is likely to evolve, in the United States, and that's one country. Western Europe the same, and certainly modern economies in Asia will be looking at the same thing. All of which says there is an industry that's going to grow. Whether it gets to 10, 20, or 30 billion at some rate, only time will tell. What we see in the way of green and clean energy implementation rates are that, for instance, solar implementation are far outstripping, the rates are far outstripping anything that was predicted in the past. So we believe that by breaking down this monolithic, meter it at the building level and pay the bill world is going to go away if technology and management can make it economic to do so. Oh, right. Right now, there is a revenue sub-metering market out there, and I mentioned it. This is landlords sub-billing their tenants, and this is a $1.6 billion market that's scheduled to, or for forecast to go over $2 billion in the coming years, maybe within 5 years. And studies in this area alone have shown that simply by moving a building from being a regime where you would pay for your energy through your lease rates to moving to a sub-metering where you're actually responsible for your own energy, that the tenants experience or the landlords notice and measure a drop in the area of 30%. So simply by making people responsible for energy, this kind of a magnitude has been shown to be possible already. So there's a major business opportunity here. We simply need to have enabling technology and an industry that will adopt the technology and bring it to market. And that's what we're here to talk about. I've got some hardware, very simple black boxes. They don't look like anything fancy. That's important because it means that it's not expensive to manufacture. What we've got inside those boxes is important, and it's mostly because of the IP. The founders of our company were very clever fellows, are very clever fellows. They're still with us. One of them is Dan Cito, our Chief Operating Officer, and one of them is Michael Ordanis, our Chief Technology Officer. They came from a rich history of technology development in GPS development, in real time, and in telecommunications. And about 5 years ago, when they were looking to work together again and looking around the environment, it was quite clear that the whole area of energy management was one area of opportunity that was glaring in their need. Right now, all energy metering, energy management, control systems in buildings have all been backwardly compatible to the days, which are still out there, of Modbus and BACnet, programmable logic controllers, all of which do not handle large amounts of data very easily. They don't handle modern cloud computing very well, and or at all, and they're relatively expensive. What we've got with this technology is what it was designed to do, and that is provide, firstly, low-cost metering at the circuit level. The idea is not that low cost is a wonderful thing from a competitive advantage, although it certainly is. The idea is that it's so low cost that people will actually install it, that the University of Waterloo facility management people might look at it and say, oh, we can afford to do that. And what it is something like 2 to 4% of what three-phase metering is at a building or what industrial controls are. Those are anywhere in the neighborhood of $2,000 to $2,500 per point per circuit. We're down in the $40 to $60 range, so that's 2 to 4%. Makes a big difference. I was in a industrial facility in Cambridge nearby not too long ago where one of those companies quoted $200,000 to do hardware and software and 6 months to 8 months of time to do 34 points. And I looked at the engineer and I said, we can do that in the next 3 weeks for $7,000. So this is the definition of disruptive. Not only could we do it in 3 weeks, we could also give them better software, more accurate software, more responsive software. And this represents a massive, massive change in what can happen with energy management in the building, industrial and commercial building space. So low-cost metering per point is part of our secret sauce. It's a popular expression. I keep getting asked, what's your secret sauce? Well, we have 3, actually. Secondly, our communications. We meter, we sample at 3,000 hertz, amps and volts, but the whole architecture and the source of our IP is that we turn that into data. And then every 2 seconds, we have a live processor in our class 2 meter, and we calculate all of the power factor, real power, apparent power, and we put all of the data for 36 circuits into a packet, and every 2 seconds we send it to the internet. So we've got real-time data. And lastly, with all of this data coming in, what we have is a big data, cloud-based enterprise software platform that can make sense out of it all and provide value to the end user, going back to and completing the circuit, if you will, back to the original thought that we need to break up and make granular all this data so that we can identify where the waste is and then take concrete action to reduce the energy expenditure in our facilities. So that's what it's all about, and we'll get into some details. We've come up with the term forensic energy management to simply make the point that line by line, this is something cost accountants will embrace. This is something industrial engineers will embrace. We've had major corporate interests in the US announce that they're going into this field, and they're talking about advanced energy management. They're talking about behind the meter energy management. It's all the same thing, and it's all very encouraging for industry as a whole. We've got what looks like a router. We've got some simple black boxes, and we can deploy this at the panel level. We can deploy it at the motor control, the MCC level. We can bring it right to the floor right to the shop floor or to the building corner office or cabinet where the electricity is distributed, and we can measure everything. So with big data and an easy user interface and an easy install, which adds to the economics benefit, we can bring this and democratize the creation of an access to energy data, and that, we believe, will be a breakthrough for companies that are in the areas of energy retail, facility management, energy services, or equipment service and maintenance, and allow them to go the next level and provide this type of management. Now, in industry, there's a thing that engineers like to call the 80-20 rule. And that's that typically what you see a meter at a building, and it's all designed so that it's accurate and it's not hacked, and the utility feels that they're getting the right numbers to bill you, and you feel that you're getting billed accurately. But some of the large users, usually big HVAC plants and everything, they have been the subject of this industrial metering technology that I've talked about. And the prevailing wisdom has always been, we can get 80% of the information we need out of 20% of the systems. So where metering used to come in at this level, if it was coming in at all, what we're doing is we're saying, no, we need a paradigm shift here, because our experience to date has been that, to quote someone, people don't know what they don't know. And we've got a growing list of anecdotes to give you some of the examples. And I gave you some at the outset. If you go down to the panel level, or to the MCC level even, all of a sudden you can get into a regime where you identify where this wastage is. You can identify power factor at 0.26 in a distribution center of 1.5 million square feet, with motors on miles of conveyors, every third motor coming in at 0.26. With this kind of information, you can suddenly shine a whole light on it, and everyone's, I had no idea. And all of a sudden, the engineers can do a feasibility study and come back with the idea that 10 horsepower motors could really be switched out to 3 horsepower motors. And that the 3 horsepower motors, after a quick test, really have the torque to move all of the goods that come through that warehouse. And so, in one fell swoop, you've identified a problem you didn't know existed. You've quantified the problem. At 0.26, you understand exactly, you can put the dollar figure on how much you're spending, because before they just had one bill, and you can identify what the payback is by coming up with a solution. So all of the examples I gave before, and that I'll sprinkle throughout this talk, all come from getting a much, much more granular. And in the future, I think that with powerful software such as circuit monitoring and other types of software that we can feed through our API, we will get to a regime where lights won't be left on, computers won't be left on, photocopiers that people think are in hibernate mode overnight and on the weekend, but are really using 30% of the total power and actually add up to 200% of the total power consumption. Suddenly, that energy becomes visible and action can be taken. Real-time circuit level metering is what CircuitMeter offers. And just going to go through a really short kind of hardware layout so that people understand exactly what we talk about before we move into the more interesting software and analytical parts. But essentially, I talked in the last slide about measuring at the MCC, measuring at the panel. From there, we install current transformers of our own specification, but it's very simple, and it can be any voltage up to 600 volts. We can measure any current. We've been up to 6,000. It's just a current transformer. It's installed to code, and it comes into one of these junction boxes. And from the junction box, we simply connect into our meter with Cat5 cable. We've turned volts and amps into data. And as I mentioned before, from there, we calculate the power, and we transmit to the cloud. We have our circuit monitoring analytical software is available to all of our end users, but in addition, we have an API that can talk to third-party systems or third-party dashboards. So many companies already have a dashboard where they're bringing in all sorts of disparate types of energy sources, and they can simply internalize our system with the API. Later this week, there'll be an announcement by a major energy retailer with over 5,000 clients that they've adopted CircuitMeter as a technology. Because I haven't been given the green light yet, I won't say who it is, but they're a perfect example. They've got their own software. It does a lot of things that ours doesn't, but ours will be the turbocharger for their entire value proposition because now they can get into granular real-time data and integrate that and start to go to market with their clients with the idea that instead of just being a retailer of energy, they're a manager of energy, and they can help them reduce their consumption, reduce their costs, and basically be much, much more efficient and be able to say to their shareholders or stakeholders in the world that they have a management policy in place, that they've got a handle on risk associated with future expenditures and rate increases, as well as their carbon footprint. And as we all know, in this regime of, or this coming regime of, in Ontario, cap and trade, but carbon pricing elsewhere, that's going to be more and more expensive. The idea that an API that can be absorbed or it can be used to take this data into other systems is also something that other partners that are starting to sign agreements with CircuitMeter have embraced because it will enable them to take small controlled solutions into various types of equipment or even more granular power factor correction simply by using the signals that come out of our platform. So that's the hardware base of it. And we do have some clever connectivity issues in that, yes, we do require an internet connection in order to communicate with the cloud, but we don't require the host to open a port. We don't go inside the firewall. Yet we do have two-way communications, and essentially these units are shipped almost empty except with a serial number, and we load the firmware from our servers at the time that the systems are commissioned. We can update them from time to time as we will, and in fact we provide circuit monitoring in a SaaS model, software as a service, so that we can continuously update, and we do foresee a huge future in the growth of the functionality of the software. So we're calling this radically new metering and energy analytics technology, and that it represents a breakthrough, that it's going to lead us to forensic energy management. And that's one of the reasons why I'm at Waterloo today. We have started to put systems in and make early stage agreements with a variety of colleges and universities. Sometimes it's been with the facilities people, sometimes it's been with the faculty, and it's primarily been in Alberta and in Ontario to date. But as a business, our model is to make agreements with large corporate entities that would resell our product and use our platform to take energy management services to their clients, companies that are in the ESCO, that are in the energy retail, et cetera. But with colleges and universities, we see a double win, a double benefit in that we're just starting out. We're creating basic software that has big data, high performance analytical capabilities, but there is so much that we're just at the beginning of. For instance, we've got the capability to change remotely the 3,000 hertz on 3 circuits and change that to 24,000 or 32,000 and just steal a bit from other, steal a bit of bandwidth from the other circuits for 10 or 12 seconds and allow a much more in-depth harmonic analysis and a whole variety of other electrical analyses that could lead to low cost but high value analytics of expensive machinery. And in the entire area of energy analytics and automated circuit analytics, as we build up this database of usage for each individual circuit and usage type, we can foresee understanding as events occurred, what happens when the power consumption of a specific device deviates beyond, say, 3 standard deviations of a mean on a data set that's been built up over continuous operation and is put together with many, many other similar types of equipment of the same specification. The whole opportunity for understanding what the performance is, what the breakdown models are, really opens up if you can collect all this data economically. So these are some of the things that we bring to the university environment, suggesting that we would love to have academic partners in this research. At the same time that we come to the facility people and say, you're the owners of the living laboratory, and as a rule, modern colleges and universities these days have adopted a sustainability, corporate social responsibility kind of mandates that put the onus on the facility management people to show progress and to take leadership in these types of areas. So by working together, I totally understand that everyone are in different streams, but by working together, I think that the colleges and universities represent a tremendous opportunity for us to work directly as opposed to working through a channel partner. And that's my purpose for being here today. So I'd like to spend a little bit of time talking specifically about the software itself, so that you know what we're talking about. Essentially, we do 2 things. We measure amps and volts and calculated power in real time, and we send it to the cloud, and then we amass this tremendously large historical database. And these 2 different functions, while they work together, give you different types of benefits when you get into the forensic energy management regime. The units are scalable, and this is really important from a functionality and an economics point. You can put, in a 600,000 square foot building, you could put 50 of these in and measure close to 2,000 points, but there's no customization of the software required. You simply plug them all in, and in our servers, all the data is put together and made accessible as a building. And you could put an unlimited amount of buildings together for, say, a Bank of Montreal or a PepsiCo around the world, and it's structured as enterprise software. So this can all come together for a portfolio at the same time that it provides the breakdown at a specific fan, pump, compressor level. And that's really important from an economics point of view. There's no additional cost. It scales automatically. At the same time, from a management point of view, where you want to get benefit, our software includes the opportunity to put benchmarks for every single circuit and the opportunity to put in specifically designed thresholds at your discretion. So one piece of equipment, you could set it at 10%. At another set of equipment, you could set it at 15 or 20 or 25%. But the thresholds trigger notifications, and that's the last that's the last bullet on the list. And so you could decide that when this compressor goes 15% above the benchmark, that you want to be known. The system will tell you that. At the outset, I mentioned mistakes, and I gave an example of baseboard heaters in a factory. That's a real example, and it's a good one to point out when people say, okay, well, once we've found the mistakes, why do we need your system anymore? Well, the mistakes came from real-life examples. One other example, a big box store, when we plugged in the system and turned it on in February, it had 7 rooftop units up there, and the building engineer looked at it, and the first thing he said was, well, these 2 were supposed to be shut down in September. They're cooling only. It's middle of February. They're running flat out. Something went wrong, and what went wrong was that in a seasonal changeover, the contracted technician who was up on the roof, he made a mistake. Well, if you start asking around, this kind of thing happens all the time, and so mistakes happen. If you go back to the stairwell, what happened is, well, we don't really know what caused the original incident, but when they corrected it, they used the notification system to say, if these stairwell heaters ever come on again, and the temperature outside is over 15 degrees and a couple other things, send an email. 14 months later, last summer in the middle of July, after 14 months of smooth sailing, the fellow got an email. And so he didn't panic on a Tuesday night, but the next morning he went in and he tracked down the problem. Somebody did something to a control setting or something, and he fixed it, and that was the end of it. So the idea of the notifications and the continuous energy management is that you can have a continuous energy audit, and you can stop what they call drift. Statistics in California have shown that after 18 months, most buildings experience some level of drift, and that to the point that there's a law that every 5 years they have to be recalibrated and undergo an energy audit. With continuous energy audit, you can stop the drift and you can arrest this kind of deterioration. So that's the high level of the software. It's heavily graphics driven. It's highly responsive. We can do 50 or 100 million data points in less than a second. And it's not sort of a geek number that, oh, that sounds powerful. It's important because when you're an energy analyst and you're sitting at your desk, you need instant answers, or you probably won't use the system. I mean, you can probably, everyone here is old enough to know or to remember what response times were like on the internet, 5 or 10 years ago, to the point now where if you don't get something in about 10 seconds, people say, system is slow. The system is slow. So in today's environment, we've been out showing our system to people that are in the field, and they say, can you do this, that, or the other? And we say, yeah, we can do that, it's done. They go, with the equipment we're using right now, that would take 4 hours to compile, and there's that 50-50 chance it might crash. So that's the kind of thing that's out there today, and that's what we're replacing with instantaneous high response software that, as we all know, really isn't that magic in comparison with all the other applications and phenomenal pieces of software that are out there. But it is pretty phenomenal for the energy environment. We're highly graphically driven because it's intuitive, and it communicate a lot of concepts. But some of the things that we can do is create an energy footprint for every machine in a factory. And we can do it for any time frame. We can do it by shift. We can correspond that with the output per shift. From a bag of Doritos potato chips, change it for a bag of Smart Food, or for injection molding machines, a batch of Muskoka chairs to a batch of patio tables. So turning a broad energy overhead into an energy footprint, and then identifying how efficient production lines are or how efficient equipment is something that is now technically feasible. In terms of demand management, most regimes, and certainly in Ontario, we pay a lot in our monthly bill for a demand charge. We pay for our kilowatt hours in terms of consumption, but we pay a lot for our demand charge. And that's based on different formulas, but essentially, quite often it's the 5 peak days. If you can identify where that peak is and when it is, and break that down into its component parts, which our software can do, then you can suddenly not only determine how to get that number down without, but you can also do it while taking into account what the disruption would be. We know of one factory that essentially went on the IESO website every morning and found out what their predicted peak was for the day, and it's sort of 7:30 at night in the winter and sort of 5 o'clock in the afternoon in the summer. And they simply said that's lunch hour, and they said everybody, and they shut down production. So they saved something like $800,000 on a $3.5 million bill, but it cost them a fair bit in lost production, and it cost them a lot in various ways. So what they can look at now is say, well, we don't really need to go from here to here. We only need to go from here to here in order to get all of the financial savings. And so now they look and say, maybe we only need to shut down 1 of 5 production lines in order to get this kind of thing. So by smoothing out your peak, by spreading it out, by minimizing the disruption, you can save a lot of money, and you can get all those benefits by understanding how your peak demand occurs and what the components are. So that's certainly a major benefit in North American regimes. Of course, we talked about carbon. This is not a tough calculation. It goes jurisdiction by jurisdiction. Right now in Ontario, we're at an Ontario level. It'll change. In the US, it's more granular. I expect that will happen here. I expect that that'll happen in breaking it up into time of day. We can change those parameters in our servers and just keep it up to date. What it means, though, at the client level is that someone who is now being asked, on top of everything else in their busy day, they're now being asked, oh, and can you tell me what that means in terms of carbon? While they don't have to spend a half a day or get a student to do it or whatever else people do. I know of one municipality where there's one person whose 40% of their job is running around collecting data and doing all manner of calculations that we can automate and leave them to be doing more high value analytics. And again, this last screen is an illustration of exceeding benchmarks. Every machine has an optimal kind of expectation about what the power consumption is. And in the world of commercial buildings, tremendous attention is being paid to the LEED standard and other standards, where in the design and in the construction, very, very efficient buildings are being built, phenomenal pieces of engineering and architecture. But what about when it starts to operate? We want to make sure that it stays operating efficiently 2, 3, 4, 5 years down the road and helps fulfill the promise of the original investment. So all of that is possible. So in forensic energy management, we've got this conservation and continuous energy audit function. We can provide, in people terms, we can provide floor by floor in a building, feedback to people to say, this is how much energy you used last week compared with the week before, so you can give continuous feedback. You can do gamification, as we're starting to see. Bullfrog Power is an early stage adopter of our technology, and they reported back in a very normal office environment without much in the way of spectacular energy usage. They've got computers and coffee machines and lights and things like that, that they've split up their office space into 4 neighborhoods, and it's a standing item on their management meetings to review each neighborhood's energy consumption. So they could ever ratchet it down and pay attention to it. Again, going back to the video, we can make the energy visible, and then even in things that aren't automated, that aren't automatic, that do depend on people flipping switches, et cetera, we can bring that to light. Precision maintenance, I think we've talked quite a bit about, but ultimately, if we can keep everything in tune, then we can save a lot of money and from inefficient breakdowns in equipment to power factor correction, and into detailed demand response. Looking into the future, and not very far into the future, this summer we are bringing what we call a J-Pulse. That would be a third module into the market, and that would allow us to accept impulse data from gas and water meters. And because our web meter is completely software driven, we can remotely reassign a couple of ports, 1 port, 2 port, 3 ports, and just tell it after the fact that it's being reassigned to be a J-box that's handling this type of pump or this type of nitrogen meter, and it's all software driven, so it's very, very flexible. With that, we can use this platform to become a complete energy system, and we're looking forward to that. We've already talked to some clients who basically said it was not only a deal breaker, but a deal maker, because we're bringing that to the stage. And lastly, of course, the greenhouse gas calculation, which can save management time. We talked a bit about this being enterprise software and that it's being scalable at zero cost. And I just want to take one moment to address it specifically. Major corporations want to have a handle on this. They're probably leading the fight in being corporately sustainable. But they have head office systems. They want new systems that are adopted in Cambridge to be able to talk to Dallas or Atlanta. They want to be able to put these systems together. So the idea that this is conceived as an enterprise system is very important. And the idea that it doesn't require specialized interfaces, ongoing maintenance, but that it works out of a box is also very important. We have a software regime that allows every user to have their own dashboard and their own account. So a CFO can look at something enterprise-wide and find out what the energy used month to date is, while a manager in a building or in a region can look specifically at what they care about. So this is all available in the software, and it covers everything. It's important, and I've said it a few times, but it's important to understand that, because if you look at what is sometimes considered to be a confusing space, there is technology out there that, for instance, might look a little bit of ours, but if you start to break it down, well, they don't actually measure voltage. They have a scaler in their software that says, well, we'll multiply it by 120. What that means is that they have an estimate of power, but they can't do power factor, they can't do real power, et cetera. So it's not only that it's inaccurate, but it lacks the ability to report on a lot of these things. So we have a full suite, and that means that we're a platform for the future as well. So I'm just going to wrap up now with some visuals to reinforce the idea. Top to bottom, we can do multiple buildings and multiple regions. You can zoom in from your office or from your cottage or from the back seat of your car through Wi-Fi or through a mobile app, and you can access all of this information. It's all available in tabular form. You can continuously download it into your own servers whenever you want. You can download it into CSV files and do further analyses that are supported in our own system. And you can get right into specific equipment on a specific floor. I think the last couple of points are this, that there's a lot of software out there and analysis that looks at things from an asset management point of view. And understanding where equipment is in a life cycle is something that a lot of models take into account, because they're trying to assess capital replacement programs and everything like that. It also is important to understand how average power consumption is calculated properly. So for every circuit, we sense when it goes to zero, and so we can calculate hours and minutes on for each one of those circuits. And that's not something that you see elsewhere. We talked about carbon and its ability to influence decisions, and then lastly, before we take some questions, I wanted to just talk about this 30%. This is a matrix has numbers that are probably too small for most people to appreciate. But I throw it up there only to make a point. We've created a matrix around a 600,000 square foot building that has a $2.5 million annual spend. It would cost us approximately $170,000, $175,000 to provide the equipment and have it installed. And it would probably cost about $24,000 a year in outsourced service charges from an energy management company to provide this service and provide the analytics, et cetera, and go back and forth. All of that sort of adds up maybe over 4 years to not a lot, under $300,000. In the matrix, we've put in, if we can eliminate usage by 1.3% in the first year and go to 2% in the second year and never find anything else. Think about the examples I was giving you. These were big numbers. These things have been running for 5 months with no purpose. If we can reduce operating hours by under 2% and maybe get another percent in the second year, if in precision maintenance, all the things that are running efficiently, if we only got 0.5% and in the second year doubled it and never got anything more, if we could save on demand management 1.5% of cost on the demand only and get that to 4% by the end of the second year and never get anything else, this would add up to an ROI of over 600% and with a payback of about 1 year. This is less than 15%, which is less than half of that 30% that we talked about as being an industry average. This is a what-if analysis, but it points to an engineering assessment that it shouldn't be really hard to get a really positive ROI in this new environment, and that the numbers should only get better as electricity prices go up and our ability to deliver the service goes down. We have one early stage client in a municipal government position who put up his hand to be the first to go to have his facility have CircuitMeter installed. And he said, Paul, he says, my bus garage is 30 years old. He goes, what do you think the chances are that it's on the cutting edge of energy efficiency? He said, I don't know what the number is, I just know what it isn't, and that's 0. So I think that these numbers point to what is possible, and over time, experience will start to be documented and bear us out. I'm going to finish with a quotation that's out of last year's Advanced Energy, and that talks about a growing tide of change and the adoption of energy management principles and sub-metering. And this quote was taken unaware of what we're doing at CircuitMeter, because we're truly 2 steps ahead of everything else that's coming onto the market. Another technology that I won't mention in this presentation was acquired last fall for $60 million by a major British company that owns a huge US retailer, and they said they were going to use it as the basis to economically provide advanced energy management services. And I can truly say they're one of the ones who don't even do half the things that we mentioned, including power factor or even active voltage management. The industry is going to move ahead, and our vision is to be a part of it and to work with clients to help us get there. I think in summary, we're trying to convince you that we have the best in market and the most powerful metering technology out there. And that's important because however many times you may have heard it, you can't manage what you can't measure, and now you can measure it. And lastly, that's important because if you can measure it economically, you can save money and have a good return on investment. And we can make energy visible. So I'd like to thank everybody for sitting through my presentation, and I think we have time for questions, and I would very much like to see what people think and get some feedback and clarify things if I can.
So the floor is now open for Q&A session. Go ahead, Professor Wood.
Okay, I'm I'm more in communications side. I do not know too much about power systems. So I'm kind of interested in when you have that, the below the box there, this side is communication. The other side, you come do the measurement, right? So I only have that meter in my house only. I don't
Right.
know what happening in industry. So in the house, you have all the switch for different applications.
Right.
Right? Even one of your slides, when you talk about CO2 emission, you show you have washing machine, refrigerators, and so on. So you actually can go down to the individual group or equipment, the same type. So on the other end, the input, yeah. So you basically take all the information from that box, like the one we have at the house, right? So is that box the same for different industrial, residential, or they're all the same standardized?
Well, in a residential, you have a circuit panel. And so our equipment works there. It's just that at a house level, you don't use as much energy, and so there's less of an attractive payback. And as a business person, it's harder for us to reach all those people. So it's much farther low. It's much further down on our list. But it certainly works. All we do is we install current transformers for each circuit, and then they're wired according to code into conduit, like you see right here. This J box is that box right there, and the CTs are basically mounted in your box, and then from there, that's the end of where you need an electrician. From there, then it's just Cat5 cable going into our meter. So it's just a matter of wiring a current transformer into the junction box. And it can be done on the home, or it can be done at a panel, or it can be done, let's see, I'll try and get a different one just to show a variety. And there's a motor control center. So it's all basically just like Lego, you know, you just with wires.
So when you say you do circuit level management, it's done in the power meter, not in this box.
Yeah, all that's happening is that at where the electricity, where the current flows with a current transformer, we measure the actual current. And across the panel or the MCC, we measure the voltage. And so volts and amps together, that equals your power.
So do you have an upper limit on how high the voltage you can measure?
We only, well, I shouldn't say we only, but we go up to 600 volts. So this is intended to be for inside a facility. We're not working in transmission or distribution environments. This is really intended to be commercial, industrial, but 600 volts is what is the upper end. I mean, you can also go down to 240 or down to 120, and that works fine. And then in terms of the actual current transformers, we have 40 amp CTs, 100 amp CTs, 200 amp CTs. So whatever the actual current, then we match the CT, and then that sends the appropriate signal into the junction box, and from there it's just it's turned into data that comes into our meter.
Right. So the signal coming in the measurement, the sampling, like you have a line for washing machines.
Yeah.
You have another line for TVs.
Yeah.
Like,
well,
coming in.
essentially, yeah, except that it's more along the lines that that's how you, if we stick with the house for a minute, that's how your house is wired. So whatever is going into your box, that's what we can measure. So houses tend to be a bit messier. Right. Sometimes, for instance, I know that if I'm running on my treadmill and somebody turns on the oven and the upstairs and the microwave, it may actually cause a fuse to blow, and my treadmill comes to a dead stop. And because they put very incompatible things all in the same circuit and sloppy house wiring. So in the case like that, if we were doing my house, we would say wall sockets, basement, oven, microwave, or something like that. So in the end, we can measure how a system is wired, which is good and bad. But essentially, for more commercial and industrial facilities, it's generally wired in a rational manner. And so when we install the CTs, we have a mapping process, and then we simply label it, and then everything goes back into the circuit monitoring database. So, yeah, so we don't actually have to be at the machine. We're at the electrical distribution location.
Okay, that's great.
Yeah,
Thank you.
yeah.
Thank you.
Yes.
So two questions then. So the actual, installation process, then you need access to the panels, and that's where all of the, actual installation happens.
That's correct.
And so, for example, this setup that you're showing right here, you're saying it's extremely low cost to put that in there. Is there an estimate on how much, for example, that kind of a system there would cost?
Well, that would be what I would call one system. That's sort of a 3J box and a voltage sensor and probably up to 36 CTs and a web meter. That's probably in the neighborhood of a couple of $1,000 and maybe $500 to install or something like that.
Okay. And then, if we had multiple panels on different floors of a building, you would just multiply that by however many.
Precisely, yeah.
Okay.
And the only thing that's different about different applications is just if you get into sort of, say you're in a big mechanical room or something like that, and you've got something like 200 or 400 amps, then the cost goes up somewhat because you might be moving from a 20 amp or a $20 CT up to like an 800 amp. That might be like, I can't remember exactly, that might be $200 or something like that.
And then the second question was, you mentioned that gas and water are something that you guys are working on doing.
Yes.
Have you looked into steam and district hot water? That's something that, down the line in terms of.
Essentially, it's all the same. I mean, because what we're doing is we're integrating a box called the J-Pulse, and electrically what it does is it accepts impulse data. So if any of the things you want to measure come in are manufactured such that they will output impulse data, then absolutely. And so many meters in a variety of regimes are equipped like that. So yeah, we're basically just taking electrical pulses. Yes.
Thank you for your very nice presentation. My question is about your product. Is it, as I understand, it could be a total substitute of meters, like for example in the house or in the building? Am I right?
Not entirely, no. I mean,
Work in parallel.
yeah, they work in parallel.
Still we need the meters.
Yeah.
Because my question was that if it is like that much cheaper in the cost, so it could be a revolution to these new smart meters and smart grids. So, but you are saying that they are not total substitute.
Well, it's a matter of a few things. I mean, first of all, the meter itself is supplied by the utility, and it's intended to do a couple of different things. One, it's based.
Mertes can be connected to your product
Yes.
if this
Right.
is the only matter. Because as I understand, when you can measure the voltage and current, so it means that essentially you're much close to,
That's correct. I think that.
or maybe it's extendable. Sorry.
Yeah. No, there's a few different aspects to it. One thing I probably didn't say was that in order, I talked a little bit about the revenue metering that goes on with shopping centers and apartment buildings, et cetera. That requires in Canada Measurement Canada certification. Largely, to a certain extent, it's about accuracy, but it's also about meeting a standard on being tamper-proof. And so we are working on a new version that would meet that tamper-proof, and we'll get Measurement Canada on that. And we've got the accuracy part, so it's merely a matter of repackaging. So beginning of next year, we can bring that to market.
You're approaching that.
Yes, we are. Yes, we are. But it's really not a technology issue. Yeah.
So you are very close.
Yeah. It's really not an issue so much of our technology so much as an issue of design and regulatory standards. Yes.
Well, thank you for today. This is great, and this is really an exciting technology. So in my previous life role, I was an electrical instrumentation and control engineer for an installing company. So we did a lot of energy audits and looking at different plants, mostly with the municipalities. So my question is, how does CircuitMeter, how are you planning to work with engineering? Do you think the engineers will be speccing your product, and then they'll hire a contractor to do the install, or do you do the design and the install, or how does that relationship work?
More the former, because we're still somewhat of an early stage company, we haven't had the sales and business development staff to really get out and work with engineering companies to a great extent. But having said that, we have started that process, and our typical way of getting to market is going to be, as I said, to work with partners in the that would actually buy our product and resell it, such as an energy retailer or an ESCO, energy management companies. That being said, I spent a good part of my career in in engineering consulting, and I understand how they work. They create designs, they create specifications for clients, and they go out to bid. So we've started to talk to some of the major engineering companies here and in the UK and starting in the US to familiarize them with our technology, because obviously they're not going to spec what they don't know about. And so we've got some very enthusiastic responses in the early days, and I can see that there are certain circumstances where we're going to start to be spec'd. And it's a little bit tricky, but there's lots of ways around it, in that there really isn't any product out there right now that has our same level of functionalities. So sometimes they can sole source us, and then we negotiate separately and from a bid perspective.
So right now you're doing the installation for your test sites as well?
We don't do installation. We basically work with the end user and use their electricians, and we train them. And we've actually not even been to site. It's very easy to install. We have some good online tools and some mobile support, but a journeyman electrician with a little bit of support from us figures it out real fast. So that's part of the answer. The other part of the answer is that if you're in a hospital or a university building or a manufacturer, they generally have electrical contractors that they prefer, and those electrical contractors have great familiarity with the facility. So they're usually a little bit sensitive about having an outside electrician come on, particularly if it might lead to a disruption in power, a mistake, or, let's face it, if they're paying by the hour and it takes 2 hours for someone to find the electrical room, well, any kind of an advantage is probably gone out the window. So it's generally preferred by end users that they use the electricians that they're familiar with. So to that end, we've made it easy, and we've focused on making the process to bring them up to speed very fast.
I got it.
Yes.
As I see, the unique selling proposition of the whole, technology is cost effectiveness. There are metering technologies available already. As I see, you are having the current transformer, voltage transformer, other thing, you are adding them in addition for metering now. How exactly are you affecting the cost effectiveness?
Well, this is all any of the economics that I mentioned all refer to the entire system. So everything together, including the CTs. But the way that we've achieved this substantially lower cost is in a couple of ways. First of all, by having a 36-port meter, or a 36-circuit meter, with this one system, you can take a number, and then if you want to get to cost per circuit, you can divide by 36. Many meters only do 3 circuits, right? So whatever the cost is, if you want to have a cost per circuit, you divide by 3. So if it costs $4,000 or $4,500, the cost per circuit might be $1,500. If ours costs $2,000 or $2,400 and you divide by 36, now you're getting it into $50 or $60. So the fact that we do multiple circuits is one part of it. But the other part, of course, is simply the design. If you look at this is a piece of telecom. It's a piece of, they're simple junction boxes, and this is simply nothing more than a router with a chip to do some calculations in it. It doesn't cost much to make. It's a board and a piece of metal. If you go out and look at other pieces of equipment, they've got steel and glass and readouts, and they got transformers, and they're what we would call hardware-centric design. This is a software-centric design. Everything about this is all about software.
Okay, so I guess we can take 2 more questions. Go ahead, you and then Holly.
Excuse me, I have a question about the data, the collected data.
Mm-hmm.
Who has the access to the data?
Well,
Is the data collected to the cloud?
Yeah. So what way it works, that's a good question. The way it works is that we transmit the end user data directly to our servers, and then whoever has the rights to manage the data,
Process it, like you have
yes,
access to it?
it comes to our servers.
So what about the privacy of the user?
Well,
Because you have a very detailed information about the consumer.
yeah, it's a very good question. We obviously have encryption and all sorts of security, but also as a corporation, we have to take this with a great deal of seriousness, and we do. With respect to the people who have allowed to have access, if it's, for instance, a channel partner that's been contracted by the end user to provide energy management services, the initial documentation makes it clear that the end user owns the data and that they're providing access to the service provider to use that data, and they can be cut off at any time. So essentially, the fact that we have data in our servers is no different than essentially any other cloud computing service provider that handles sensitive data. The banks have all my financial data. I don't worry about it. We're certainly moving into an era of cloud computing because of the great power of the economics.
So for the software, like the software, like the consumer will have access to that software. So the consumer who's the one to take decision to see that that equipment is go beyond the threshold and.
That's right.
Even if the consumer is like in residential, we don't understand like if this equipment is.
Well, that's a very good point. But so you've sort of probably laid out the base case of why we're not initially targeting residential sector at all. But it's also the same point as to why we are largely targeting service providers and channels, such as large energy retailers and facility managers, because they have professional staff that will learn the system, be trained in the system, be trained in energy analytics, and provide that to their clients as part of the service that they pay for. So we believe, as you've just laid out, that there is some complexity to this, and that professionals really need to become trained and expert in how to interpret and use it. So that's in a good measure why we've adopted the business model that we have.
So Paul, it won't be wrong to say that the decision maker is, again, the end user.
That's correct. So for instance, if the end user is PepsiCo, and they are happy to outsource energy management to JEXA or somebody like that, then they've made a commercial decision to outsource the management of their energy to that company, and then they have a contractual interaction that says, you're going to provide us with these services, these reports, these recommendations, et cetera, et cetera, et cetera. At the time that they cease to become happy with JEXA and they said, no, we're going to go with Direct Energy or somebody else, then access to the systems to JEXA would be cut off, and we would provide access to the systems to Direct Energy as directed by the end user.
Do you guys have access to the data in terms of benchmarking and other things that you might, from a big data perspective, want to do things cross facilities or cross companies? Is probably not sharing that anywhere, but is that something that is?
We retain access to the non-specific data specifically for those purposes, and that's part of the agreement when we when we enter into the SaaS agreement with the end user. I have no problem with that. I think it's a win-win all the way around. And so I would say to the end users, and we really haven't had any pushback yet, is that you'll be the biggest beneficiaries. You throw this anonymous data into a pool and leave it to us to amass it over time, and all of the generalized benefits that can come out of the insights that we gain are going to feed right back to you. So it's only client-specific data that is scrubbed and eliminated.
So one last question.
Yeah, thing is, I know you're getting questions from hardware, software, and all aspects.
Mm-hmm.
Just had a quick question regarding the software. So I understand you're sending information, and the end user has the access to all information. but is there kind of like an add-in to the software where you can actually optimize the data you have? Like for instance, because what I understand that you have data and that there should be a person with some background of what's going on, but if there was a kind of an optimization add-in that could actually provide techniques on how to, or distribute the load, for instance, if it was in an industry, or if it was for the residential sector where you have different peak hours of prices corresponding to different, so you could kind of separate or optimize your operations accordingly.
Okay, so I'm gonna answer a different question than what you asked, and then I'm gonna answer your questions. So our software basically allows you to do a vast myriad of presentations, manipulations of the data itself. If you want to, however, do other things to actually change the data, or to move into functions such as you alluded to, wanting to get into sort of localized control regimes and everything, then that would be external to our circuit monitoring, and you would use our API to access the data and pull the data into your own environment. And as I mentioned in my presentation, we're working already with a number of companies that intend to do just that. So then we're providing the conduit out, but there's a whole universe of things that can be done with it, which is one of the reasons why I'm at Waterloo today. I think that the imagination, it's kind of like at the beginning of the internet. No one knows where this will all go, so the more people that we have playing with it, the better.
Yes.
Is there any other questions?
That's it.
Wonderful.
Okay. Paul, I would like to thank you for your wonderful presentation, and the wonderful audience. Thank you so much.
Thank you.